Throughout history, more than 208,000 tons of gold have been extracted, and it is estimated that over 40% of this gold is stored as bars in the reserves of the world's leading banks. But how is a gold bar made? To find out, let's travel to Switzerland, the global leader in gold refining. Since ancient times, gold has been a symbol of wealth and power. Egyptians, Greeks, and Romans used it in jewelry, coins, and as offerings. However, in the beginning, gold was transported in irregular shapes, making its use and trade more complicated. Over time, especially in ancient Rome, more uniform gold bars began to appear, facilitating trade and storage. The significant leap occurred during the Middle Ages, when alchemists and blacksmiths developed more advanced smelting techniques, creating regularly shaped bars. Commercial cities like Venice and Florence quickly adopted this practice, boosting international trade and banking systems. During the 19th century gold rush, the need to transport and store large amounts of gold led to the standardization of bars, marking their weight and purity. In the 20th century, technology further improved the process with graphite molds and high-temperature furnaces, producing high-quality bars. Today, gold bars are a symbol of financial security and are crucial for banks, governments, and investors seeking to protect their wealth. So how are the purest gold bars in the world made? It all starts with gold extraction by identifying gold deposits, which can be found in underground mines or open-pit operations. In underground mining, tunnels and galleries are excavated to access the ore, reaching deeper and richer gold veins. On the other hand, open-pit mining involves removing large amounts of soil and surface rock, which is more suitable for shallow deposits. Once the ore is extracted from the mine, it is transported by trucks or conveyors to the processing plant, where the preparation for refining begins. The next step is crushing or grinding, which takes place at the processing plant. Here, the ore undergoes an initial crushing stage using jaw, gyratory, or impact crushers to break down large rocks into smaller pieces. The crushed material is then sent to mills, such as ball or rod mills, where it is ground into fine particles. This process is crucial because reducing the ore's size exposes more surface area of the gold particles, facilitating their subsequent release and separation from other minerals in the rock. Once the ore has been crushed and ground, the cyanidation process begins, one of the most effective and common methods for extracting gold from ore. This process involves immersing the ore particles in large tanks containing a highly diluted sodium cyanide solution. Cyanide acts as a leaching agent that dissolves the gold, forming a soluble gold cyanide complex. To improve the process's efficiency, pH levels are carefully controlled, and oxidizing agents such as oxygen or hydrogen peroxide are added to facilitate the dissolution of the precious metal. This step is crucial as it allows the gold to transition from a solid state to a liquid solution, paving the way for its recovery. At this stage, the gold is dissolved in the cyanide solution, so it is recovered through a precipitation process. A reducing agent, commonly zinc powder, is introduced, triggering a chemical reaction. This reaction causes the gold to be released from the solution and precipitate as a golden sludge or powder. During precipitation, other elements, such as silver, may also precipitate if present in the solution. The result is a gold-rich mixture collected and then filtered to separate the precipitated gold from the remaining liquid. This golden sludge is the precursor to doré, an impure gold alloy refined in subsequent stages to achieve high purity. Once the golden sludge is collected, it undergoes a smelting process in an industrial furnace that reaches temperatures above 1000 degrees Celsius. At this stage, the extreme heat melts the gold, allowing it to separate from other metallic and non-metallic impurities in the mixture. This smelting process produces a liquid material where the denser gold settles at the bottom, while less dense impurities float to the surface and are removed as slag. Following the initial smelting, the gold may still contain small amounts of other metals or impurities, so it enters the refining phase. Various techniques exist to purify gold, including electrolysis and chemical methods. In electrolysis, impure gold is used as an anode in an electrolytic solution, while pure gold sheets act as cathodes. As the electric current passes through, gold ions dissolve and deposit on the cathode, resulting in a highly pure product with a purity of 99% or more. Alternatively, acids can be used as part of the refining process. This method, known as aqua regia refining, involves dissolving impure gold in a mixture of hydrochloric and nitric acids, then precipitating it again, removing impurities, and producing gold of exceptional purity. These techniques ensure that the gold meets the quality standards required for its commercialization and use in industrial and jewelry applications. Once the gold has been melted and purified, it is poured into molds to shape it and prepare it for use or sale. This step is crucial to ensure the uniformity and quality of the final product. The molds, usually made of graphite, are ideal due to their ability to withstand extremely high temperatures without deforming or chemically reacting with the molten metal. Additionally, graphite has properties that facilitate the release of the bar once it has solidified, preventing the gold from sticking to the mold. The pouring process must be performed carefully and precisely to avoid the formation of bubbles or structural defects that could compromise the bar's integrity. After the molten gold is poured into molds, the cooling process begins. This can occur naturally by leaving the molds at room temperature, allowing for more gradual and uniform solidification. However, some operations use accelerated cooling by immersing the molds in water, a process known as quenching. This not only reduces waiting time, but also affects the mechanical properties and appearance of the bar, as rapid cooling helps prevent the formation of large crystals and improves the metal's internal structure. Once solidified, the gold bar can be removed from the mold, fully cooled, and prepared for further processing, marking, and storage. After the gold bars have completely cooled and been removed from the molds, they undergo a rigorous inspection process. This step is essential to ensure that each bar meets the international standards for purity and weight established by the industry. The inspection includes both visual assessments and advanced tests, such as spectrometry, to confirm the gold content and ensure the bar has no defects, porosities, or residual impurities. Quality control may also involve weighing the bar, which must precisely match specified standards, such as 1 kilogram bars or 400 troy ounces. Once the inspections are passed, each bar is marked with vital information. This marking process includes details such as the exact weight of the bar, the percentage of gold purity, usually 99.5% or higher, and a distinctive seal from the manufacturer or refinery, certifying the gold's authenticity and origin. In some cases, individual serial numbers are included to facilitate traceability and identification in audit records. The result of this process is a bar that meets all the requirements for commercialization and use in various applications. The marked and certified bars become valuable assets for investors seeking a safe haven for their capital, financial institutions maintaining reserves of value, and manufacturers requiring high-purity gold for creating jewelry and high-tech electronic devices. This step not only ensures the product's quality, but also provides the confidence needed for its use in international markets and high-value transactions. Once the gold bars have been smelted, inspected, marked, and certified, their storage becomes a critical stage to preserve their value and ensure their integrity. The bars are stored in highly secure facilities known as vaults or strongrooms, designed to protect precious metals from theft, physical damage, and environmental deterioration. Vaults feature advanced security measures, including biometric access controls, surveillance cameras, motion sensors, and highly trained security personnel. These facilities may belong to banks, exchange houses, government entities, or private companies specializing in precious metal custody. The gold is stored on metal shelves or in compartments specifically designed to support its weight and facilitate inventory management. Each bar is placed so that its identification marks are visible, allowing for quick and efficient control during audits or inspections. Storage spaces must maintain controlled temperature and humidity conditions to prevent label oxidation and preserve the material's quality. One of the main reasons for manufacturing bars in standardized rectangular shapes is their ease of handling and storage. The flat surfaces and well-defined edges allow them to be stacked and organized securely in vaults, maximizing space and simplifying inventory processes. This format also facilitates transportation, as the bars can be moved and accounted for with greater precision and speed compared to irregular or more challenging shapes. Additionally, each stored bar is recorded in a digital inventory system, ensuring its traceability and simplifying inventory management. These records include details such as weight, purity, serial number, and storage date, providing transparency and confidence in the metal's custody. And that's how the purest gold bars in the world are made. Tell me, what did you think of the process? Let me know in the comments. If you enjoyed the video, click the like button and don't forget to subscribe to the channel. In the windows you'll see next, there are more videos that might catch your attention. Don't miss them. See you next time.